Press the play button. The music didn't come from the speaker, but from the radio in the next room. This magical infinite journey starts with the first component you are about to solder, 2N219 transistor. It is a high-frequency power amplifier. In the final stage, amplify the weak radio signal, giving it enough power to travel through space on its positive pole. We solder a 100 kilo ohm resistor. This resistor is crucial. It sets a stable static operating point, ensuring it operates in an efficient and linear area, which lays the foundation for a clear signal output. Then we connect a 330 picofarad capacitor. In the high-frequency world, it acts as an agile traffic director. It is mainly responsible for filtering out the noise and cooperate with subsequent components and constitute part of the signal path, ensuring that high-frequency signals are unobstructed. Now turn to the audio section. We solder a 10 kilo ohm resistor. It sets the path for the upcoming sound signal, and initial bias.it is the first link in the entire audio processing chain. The core of sound processing, the BC547 transistor, as a high-gain NPN transistor, it acts as an audio preamplifier here. The weak sound electrical signal will be significantly amplified here for the first time, ready to be loaded onto radio waves. At its collector output terminal, we connect another 330 picofarad capacitor. It is a coupling capacitor. Its mission is to let the amplified audio signal pass smoothly, while blocking direct current voltage, and achieve the smooth flow of AC between the front and rear stages. It realizes DC isolation. To provide a pure and stable working environment We add a 40 microfarad 25-volt electrolytic capacitor, as a power filter capacitor can effectively absorb voltage fluctuations in the circuit, like a reservoir, to smooth the flow, preventing noise from being generated by power interference. Now, the ear of the circuit is a capacitive microphone. It converts the sound waves in the air into a weak electrical signal. It is the source of sound in the entire system. The two leads are connected to the signal and ground terminals. Between the microphone and the amplifier, we connect a 27,000 ohm potentiometer. This is an adjustable resistor. By rotating it, we can change the signal strength of the input amplifier, thereby achieving flexible control of the transmission volume. Near the power pin of the amplifier, we connect a 40 microfarad capacitor in parallel, which forms a double guarantee with the previous one. It further ensures the audio amplification circuit works. In a more stable DC environment, we solder a 330 kilo ohm resistor to the emitter. It and the surrounding components together determine the voltage of the audio amplifier and amplification factor. This value directly affects the depth of audio modulation. Back to the high-frequency part, connect another 330 picofarad capacitor. It is directly related to high-frequency oscillations. The feedback and coupling path of the signal. It is indispensable for maintaining oscillations, and indispensable element. We add a 5,000 ohm resistor. It is usually used to precisely set the current or voltage to the static operating point and modulation sensitivity for final calibration. Then add a 10,000 ohm resistor. It and the previous resistors together form a complete transistor. To form a bias network, ensuring that each transistor can immediately enter the preset best working state. The core control component is here, a variable capacitor of 0 to 10 picofarads. It works with the inductor, forms a resonance circuit that determines the transmitting frequency. Rotating it, you can precisely adjust the transmission frequency. Anyone within the range of 88 to 108 Ms, any blank channel closely connected to the variable capacitor, is a 0.1 microhenry inductor. Together, they form an LC oscillating circuit. This is the heart of the entire transmitter. It is responsible for generating the pure waiting to be modulated by sound, high-frequency signal. Next to the resonance circuit, we solder a small capacitor of 4.7 picofarads. Its capacitance is very small, which is crucial for high-frequency signals. It is mainly used for precise fine-tuning of the oscillation frequency, and for signal coupling, we add a 1 picofarad capacitor. It is located on the signal's path to the antenna or amplifier's final output path. It is the last DC isolation guard. It only allows pure modulated high-frequency signals to pass. Finally, connect a metal wire as an antenna. It converts radio waves into electromagnetic waves and radiates to space. Its length and shape directly affect the transmission efficiency and coverage. The range is to connect a 12-volt battery to the circuit. Power is turned on. All transistors and components are activated. The circuit starts to work. The radio carrier wave is generated in the air. The exciting moment has arrived. Play music on your phone and connect the audio input circuit to an FM radio, and tune it to the frequency we set. After a moment of noise, the music comes clearly. This proves that the sound has been successfully encoded on the radio wave, completing a wonderful journey from wire to space.